Hello again to everyone. It's my pleasure to start this webinar number 30, sorry, in the Webland project, as I explained soon, with the topic of industrial cleaning. We have the pleasure of having you on board with us, as mentioned earlier, more than 30 registrants from different companies and institutes in Sweden, as well as university. So welcome to everyone again. As mentioned, this is webinar number 30 from the WebLearn project. WebLearn is a project that is funded by KK Stiftelsen as well as Jönköping University with the aim of conducting focused and spot-on webinars related to metal and polymer component manufacturing. Since September 2020, the project has been started and it will continue until the end of this year. But anyhow, within our department at Jönköping University, we have a plan to continue the activities based on this project, even after the project ends. We have been conducting more than 30 webinars. It means almost every 2 weeks since the beginning of the project. We have been having webinars related to, as I mentioned, the topic of metal and polymer component manufacturing, and we will have a few more until the end of this year as planned. You can read more about the project in the address that is provided in the slide, ju.se/weblearn. You see the moderators of this webinar today, myself and also my colleague Maximilian, who will take care of technicalities and running the webinar today. But more importantly, you see our webinar presenters today. We have the pleasure to have 3 of our colleagues from RISE, Research Institute of Sweden, who will present this interesting topic for us. I think Charlotte, Fabio, and Emma will present themselves soon. So I save the time and leave the introduction to my colleagues at RISE. This is the agenda for today. After my short talk, our colleagues, the main presenters, will start their presentation until roughly 2 or 10 past 2. And after that, we will have a panel and discussion in a group to discuss the topic further, and also use the opportunity to also look for collaboration possibilities and networking. We hope to wrap up the webinar by 2:30 Swedish time. A few notes about how we conduct the webinar. We would appreciate if you turn off your microphone during the webinar. Questions are more than welcome during the webinar, but we appreciate if you could ask them and raise your questions in the chat in Zoom. You can send it either to myself, Ehsan, or send it to everyone. And we will take care of them after the presentation ends from our lecturers. The panel discussion is an important part of our webinars. We would like to have both way interaction with the participants in our webinar. So please make sure to participate in the discussion if you have anything to add to the discussion or if you have any questions. We would highly welcome that. Our webinars are recorded and the recorded material will be available, will be provided to you afterwards. And if you don't like to be in the recorded videos, please turn off your camera during the presentation. The discussion and the panel discussion will not be recorded, so you're more than welcome to turn on your camera and your microphone and contribute to discussion as you wish. Due to pandemic, I think all of us are familiar with Zoom in some way, but in case some of you have forgotten or do not know, these are the main functionalities that you can find in Zoom and the main bottom menu for where to mute and unmute your microphone, turn on and turn off your camera, as well as the chat function where, as I mentioned before, you can raise your questions or any comment during the webinar or even after that when the presentations are done. That was from my side. Without further ado, I give the scene to my colleagues at RISE and also Maximilian. Please, floor is yours.
Yeah, Charlotte, please start. And don't forget to unmute yourself.
Yes, now can you hear me?
Yes.
Yes, my unmute, the microphone disappeared when I got control, so I didn't have a microphone to press on. So thank you, Essan. As you said, it's me, Charlotte Ireholm, and my colleagues Fabio Pezzotti and Emma Holmström that will talk about industrial cleaning. So first, I will just say a few words about RISE, unless you haven't heard from or of what we are, what we are for Institute. And then Fabio will continue with some general information or general industrial cleaning topic. And then Emma will talk about particle cleanliness and what we work with there more specific. And then we have some examples of projects, ongoing research projects on the topic that we will talk about. So, but I'll start with some slides about RISE, which let's see now if it works. If I press 2 times, maybe I should have a next slide. No. So Research Institutes of Sweden, we work with new solutions for a sustainable future in many ways. And yeah, we are approximately around 3,000 employees all over Sweden, and some sites also abroad in France and one in Norway. We have 130 different test and demo environments or application sites where you can work with various application methods, for example. We are funded, yeah, almost half of our funding is from the industry, and the rest is from different types of funding from public and state, and a smaller part from European funding where we apply for money and work for. Yeah. And our research areas or topic are, as this picture shows, quite wide. We used to be 35 different research institutes, and now we all consolidate in one, in RISE. So everything from energy, AI, marine growth, and to food, materials, and transport and mobility. So this picture just shows the widespread or of different topics that we cover. And how do we work with these areas then? Yes, this picture show then, so you can package them into 4 different types, I would say. So transition management to the left, and lifelong learning. That is maybe not where we represent the most, the ones that are here today, but the second square there, applied research and development, that's where our subjects are, and also we have a test, certification and calibration part, which is also partly of what we do. I mentioned sustainability at the beginning, and of course, as almost all companies today work with the sustainability goals, where we picked out 5 of them that is mostly actual for us at RISE. Some examples, I mentioned that we have a lot of different test and demo facilities, from AI to additive manufacturing. Yeah, there's a wide range, different topics. So we are these 3,000 people divided into 5 different divisions. Bioeconomy and health, digital systems, materials and production, built environment, and safety and transport. And materials and production, that's where you find us. So we work with manufacturing processes and more specific surface technology or surface treatment. And here you find me and Fabio and Emma. So me and Fabio represent surface treatment. So where cleaning normally is the first part, and then we have following steps with application of different coatings, for example, and also we work with the evaluation of the final surface, so to say, or different surfaces with different coatings or surface treatments on them. We didn't say if we were going to present ourselves more specific, but maybe a few words then. So I will give the word to Fabio and Emma also before we start on the cleaning part. So I've been working here at RISE, is it 7 years, with more with the surface treatment processes and application of paint and powder coatings and so, but as I said, the cleaning steps, or the before you start doing any treatment of the surface, you need to have a proper clean and good surface. And we work with all types of substrate materials, so plastics, metal, composites or so. Yes, so Fabio, do you want to say something about yourself?
My name is Fabio Pezzotti. I've been working in RISE for the past 4 years. And as Charlotte said, I work in the same group as her in surface treatment, basically all related to surface preparation, cleaning, and then application of different kind of coatings, and also regarding tests and validation of coatings properties. And it's Charlotte said basically a lot of the things that we work with. So I'll leave the word to Emma.
Yeah, my name is Emma Holmström, and I've been working at RISE since 2014. And I have been working with particle cleanliness, both testing and the network. And I'm going to tell you more about that later. So, yeah.
Yes, so then we can, I think, start with the cleaning topic. And yes. I think you have
now
control.
I should have the control. Yeah.
And now I can mute and unmute again. That's nice.
Let's see, industrial cleaning. Yeah, now I can change. So, hello everybody. So why is cleaning important? During a lot of manufacturing processes, you can say that there are different materials that are applied to the substrates during the production. This can be very different depending on the manufacturing process, but it can be from oils, emulsions, lubricants, and those, after the manufacturing process, these materials have to be removed. Other types of pollutants or contamination that is important to clean are produced during the manufacturing processes, and these can be chips or particles coming from the components or the pieces that are manufactured, or it can also be from the formation of oxides or other species that are produced during the different processes. And in many cases, or I would say in most of the cases, all of these contaminants must be removed before the next process or before having the final product. Just as an example, this is a little bit of a flow schema of production of gears, the manufacturing process. And as you can see in all the different processes, there are lubricants or emulsions that are added during the process that will need to be removed in the different stages afterwards for cleaning. And before the packaging or before the final product is sent to the customer. It can be from cutting oils, emulsions. It can be, some of the components can come from the washing steps, where some of these previous contaminants are intended to be removed. And also it can be in the final washing steps where you have some washing emulsions or some corrosion protection fluids, especially for metallic components. So in order to clean or properly clean the components, energy has to be provided to the system, and this energy can be provided in 3 different ways. It can be chemically, thermically, or mechanically. It is important that all of these 3 different types of energy, together with how long is this, are the components or the parts going to be cleaned, be in be correlated. And as I said, like the physical forces or the mechanical energy that is put into the system in order to clean can be applied with by spraying, by agitation, dipping. There are different methods, mechanical methods used for cleaning components. Regarding the thermal force, well, of course, it is combined or with the temperature at what the components are cleaned, and this is this kinetic energy that allows a better cleaning of the systems. And the chemical force is a more molecular cleaning, as I would say, as there are some chemicals that can improve the desorption or the dissolution of some of the impurities in the system. So in order to have the optimal or a very or a good cleaning cycle, all these cycles must be complete. That is to say, like the total energy in general has to be more or less the same, but it can depend or it can vary depending on which type of contaminants, which type of components. But at the end of the total amount of energy should be more or less the same. So you can split these different types of cycles or stages depending on the needs of the component. So you can, in some components, you might need more chemical washing or chemical energy. In others, you might need more time, but at the end, the cycle must be complete and it should use approximately the total amount of energy. Regarding the thermal energy, as I said, it's very related to the temperature at which the cleaning process is being held. At higher temperatures, it increases the speed of the washing process. It can also reduce the viscosity of some of the contaminants, in this case, oil, dirt, and it can make it easier to remove. One of the backdraws with the thermal energy is, of course, the consumption of higher temperatures means that you will require to give more energy to the system. And this could be not the best energy efficient, as you can say it so. But as I said below, before, it's all a balance between the different stages in the cleaning process. The mechanical energy used for cleaning, it can come from different types of process, from spraying, shaking, brushing, or ultrasound. There are other, of course, there are also other mechanical methods that can be used, and it will depend a lot on which type of process you are running, which type of components you are running. Regarding the chemical energy, basically, or more, basically it is found in the type of washing liquids you are using. This how they interact with the contaminants or with the oils or with the emulsions that you have in your component or in the surface of your component. And depending on the activity or how they give this energy, this chemical energy to the system, they can be good components or more active components or less active, depending on the chemistry, of course, and this compatibility with the system. And as I said, also these 4 type of cycles or 4 type of stages need to be correlated. So there are correlations between the temperature and the mechanical effect, and one should find which one is the more acceptable, or where can you put your process parameters in order to have the best cleanliness or the most acceptable cleanliness. And the same runs for temperature and time effect. Depending on how much time or how less time you have on the process, you can have a more acceptable cleanliness. Something regarding the chemical energy that needs to be provided to the system has to do with the strength of the binding of the contaminant to the surface. How strong is this contaminant being attached to the surface? And this bonding or this energy will depend also on how distant or what's the distance between the substrate and the contaminant. If it's in the outer layer, or if it's in an absorption layer, or if it's in a reaction layer. So the chemistry of the cleaning fluid, if you could say so, has to be in accordance with this type of breaking this or reaching this amount of energy in order to get to the different layers where it can be. And well, once we understand more or less what are the 4 different stages for the cleaning process, it is important to select and design the cleaning process that is more suitable to our component or to the parts that we want to clean. And this depends on different things and in a lot of variables. It can be from the previous step, where does it come? What was the process before, and what type of contaminants does this component, does this part is bringing to the washing step? How many related to the components? What's the volume of the component? What's the amount of contamination? If you want to have a continuous or a batch process for cleaning the components. Related to the type of contamination that comes from the previous steps, it can be either organic, it can be salt contamination, or it can be particles. One also should consider the environmental and health issues of the cleaning process in terms of water consumption, in terms of health risk or exposure to chemicals, either by the users or by the operators in the factory. Also, something that should be considered is the energy efficiency of the process. That would require the process time, how much time are the components going to be in the washing or in the cleaning process, and what are the temperatures at which the processes will be held on. And at the end, which will be the subsequent processes, which are the processes that will follow the cleaning. Would it require an extra rinsing? Would it require purification of the water streams coming from the cleaning process? And what type of cleanliness specifications or requirements are necessary for the next process? What can be the influence in the cleaning efficiency? Of course, there are many parameters depending on the type of process and on the type of components or pieces that need to be cleaned. But first of all, it's what types of contaminants are to be removed. We'll give a little bit more detail in the next slides. What's the amount of components or the volume of components that needs to be washed away? What are the cleaning requirements regarding the subsequent treatment? The composition of the contamination on the surface. What's the geometry and design of the component and the surface mechanical properties? The resistance of the surface to the cleaning agent. That has to do a lot with what I explained earlier about this chemical bonding, or how these contaminants attach, or how much they like to be on the surface, and how much difficult would it be to take them out. And the condition of the bath, which could be parameters, which could be the contaminants that one can have in the bath. So one can choose, not one can choose, but yeah, how clean or how clean the component at the end is, how clean the component is at the end will also be determined by if the bath is clean or if it has impurities. So it's also important to have an eye or check how the baths are contaminated. Regarding the impurities to be cleaned away, as I said, they can come from different sources. It can be either from the washing liquids or from the additives or emulsions or oils, lubricants that one can add to the process, or they can also come from the manufacturing process by itself. So it can be particles that basically they come from the manufacturing process, and it can be chips or small particles that can interfere with the system, and they can bring problems in subsequent processes. Regarding organic substances, it could be oil, greases, emulsions, and basically most of them come from the additives or from the cutting oils or from the emulsions that are used during the manufacturing process. And these films normally stick to the surface of the components, and in some cases it might be more or less difficult to take them out depending on the nature of the substances and of the cleaning process. Salts, it's basically most of the salts are formed within the surface during the subsequent processes, and it's important to remove them as they can give rise to corrosion. That's particularly important for metallic components and for electronic components. Other impurities that needs to be cleaned away are abrasives or polishing agents that are also used during the manufacturing processes. Flukes, that I didn't know the word in English, but in Spanish I know it. But it's used when you are soldering different components. And during different steps of the manufacturing processes, you might require to add anti-corrosion agents to preserve the parts during the production process, and also at the end of the production cycle. Concerning the requirements or how clean must a component or a part be, it's very difficult to define it, as there could be many different standards or many different parameters that can tell you how clean a component is. It depends on the manufacturing process. It depends on the end use. There are different types of guidelines that are used depending on the types of processes and depending on the use that the component is going to have. But it is difficult to define it, to have one definition of a clean process or of a cleaning process, as well as it's difficult to measure. So there are different standards or different limits depending on the type of process, depending on the type of component, depending on the end use.
We can also, if it's okay, if we can add something about storage. I mean, even if you have a clean enough surface, then if you manage to define that it's clean and everything, but sometimes also then you need to store your component or send it somewhere before it goes to the next process steps, for example, and then you don't know if it's clean then. So it's always a problem, and since it's not so easy to define often, yeah, there's a problem with the storage and handling of parts after cleaning and after defining if it's clean or not. So makes it more complex.
Next slide. Now I cannot change slides. Now. Oh, no. Yeah, just as an example, this is a classification of the cleanliness grade This corresponding to an ISO standard 85.1 that is, if I remember correctly, is for metallic substrates. And as you can see, there are different kind of grades from 0 up to 3, and each grade has a different limit or barriers depending for each different kind of contaminants, either oil and grease, salts, or other type of contaminants called standard fixed contaminants or loose contaminants. It can be from oxides to slag, or to more loose contaminants like dust or dirt. And then again, this is just a reference. A company might require, or a manufacturing process might require different cleanliness grades or different limits for their components. So a lot of companies can use this as a reference, but they can also have some internal standards or internal limits for the different kind of particles they require. And this is just some of the examples. It can be, they can have more parameters in terms of which type of particles or contaminants they want to measure. And yeah, according to this standard, depending on the type of process, they require the different cleanliness grades. In the case of the manufacturing, as in the cutting processes, plastic processing or thermal treatment, it requires higher cleanliness grade. And depending on there, you can see that subsequently the cleanliness grade is lower. It's a bigger number, but it's a lower cleanliness requirement, depending on the type of process that is necessary. Regarding the mechanical methods for washing, it can be different methods like spraying or dipping, ultrasound, but I think we have a slide for ultrasound cleaning next. But it's basically putting mechanical energy to the system in order to try to remove the contaminants, either if they are loose or if they are loose, or how do you say, the contrary of loose.
Not fixed to the.
Yeah. That will also depend on the chemistry and on the other two parameters regarding time and temperature. Yeah, so I think we have a couple of slides of some mechanical cleaning. Ultrasound uses cavitation for cleaning. It's a high frequency ultrasound that is sent to the liquid, forming bubbles, and these bubbles explode or implode, not explode, and they produce cavitation. And this can be a very good or bad cleaning method, depends on a lot of the component, on the chemicals that needs to be, or on the chemicals or impurities that need to be cleaned away. But it's has some limitations in terms of volume, or in terms of what type of components can be put inside. Another mechanical method that is used quite a lot in the manufacturing is tunnel washing, where you have all the components hanged up in a washing tunnel, like the word says, and they can be inside. They can be sprayed. Most of the times they are sprayed, and yeah, and sometimes in the final stage of the tunnel washing can also come some drying of the components. It is also used, besides cleaning, it can also be used for phosphating or even for pre-treatments, this type of tunnels. And this is chamber cleaning. This is more a batch-wise process in which determined amount or determined volume of components is put into a chamber, where basically it can be applied heat or sometimes vacuum to try to remove some organic contaminants, for example.
Yes, then we come back to the cleaning circle in the middle here. As Fabio mentioned before, we have thermal energy, mechanical energy, time, and chemistry that is had to add up to 100% and then result in a clean surface. But the choice of how we choose the different parts, of course, has impact from other parameters or sources, such as it depends on what type of application we are looking for, what type of substrate we are cleaning, if it's plastic or if it's metal, and also the level of, it says dirtiness here, but the level of contamination, how much contamination, what type. So that can, of course, has to take into account what chemistry we will use and how much mechanical force we need for the cleaning. And also, I think we also mentioned already the environmental impact, and then it's both the work environment for operators and so on, but also, of course, the sustainability part with more, not work environment, but pollution and these things. And also, of course, the following process steps, what is happening with the part after the cleaning step. And last but not least, of course, the economy. So can we how much thermal energy do we have, can we afford, especially now when the energy price is going up? But yeah, so a lot of different things that sets our cleaning circle parameters. And now I think
it's me that has control, right?
Yeah. So I think next slide is more or less, some examples that I maybe already mentioned. So substrate material impact, so steel or metal, plastic or composite, what type of contamination, and subsequent process steps. And these all then, these parameters make our choice of process, as we saw on the last slides, of Fabio's last slides. What type of washing equipment we can use is also then steered by these parameters. So
and also the type of cleaning equipment or industrial cleaning machine, it's a combination of all these 4 parameters. Yeah, can be mechanical and chemical at the same time. And
exactly. And the chemistry of the washing liquid that we use can be more or less complex then. First of all, we have to look at what type of contaminant we are to wash away then, if it's oil, wax, or grease from previous steps or previous process steps, or if it's salt particles or other contaminants. So we have, there are solvent-based and water-based cleaning liquids, and as you see in the picture, mainly solvent and surfactants in the solvent-based one, but more complex formulation in the waterborne example here. So except for water, which is the majority of the content, of course, we have surfactants and alkaline components and other here with a little asterisk, for example, corrosion inhibitors. And if we have a water system, you might need to add some biocides, or other additives, so to say. But if we look a bit more into the surfactants and why they are needed, you can see on the next slide. So a surfactant then is a surface active agent, more or less. So normally it's contains of a the schematic picture here to the right. Then you see the hydrophilic and hydrophobic part, which is good in a water-based system. Then if you have surfactants, then the hydrophilic part is in the liquid phase in the water, and then the hydrophobic part of the this surfactant seeks to a hydrophobic surface. And if you have some at least of contaminants or what you want to wash away is hydrophobic, so then the surfactants adhere to that surface, and then with the help of the other parts of the wash or the cleaning cycle, for example mechanical or temperature, it adheres there, and then the contaminants is covered with surfactants and washed away, so the surface is then clean. If you simplify this a bit, but that's the surfactant part. Temperature we already mentioned. It's one of the 4 parameters. So it influences, of course, the drying time. If you have a high temperature, higher temperature, the water will leave faster, and how long the water stays on the surface has an impact on the corrosion, of course. And also, but there's a limit, of course, both in energy efficiency, but also for the material that is washed, how high temperature you can use in your washing system, or if you in your cleaning process.
And temperature it can also be related to the efficiency of the cleaning chemicals, or they can be more efficient at higher temperatures than at lower temperatures.
Yeah, exactly. Yeah, true. And it's the same with the washing time. If you have a process, you can't have too high time or too long time to be efficient. So that is, of course, steering how the washing time can be. And this also, of course, can have a large impact on the substrate, and also on the chemical used, so to say. But for your specific system, it's trial and error to see how short you can make your washing and to be more and more efficient. But there is a limit, of course, somewhere, but it's can be difficult to calculate in advance. It's normally this trial and error that is valid. We can take the next. So we've been talking about washing liquids, and then often you have then a bath. If you have an open bath, then of course some of the water evaporates, so you have to adjust and add some water, and also some of the additives and the chemistry in the bath is used, so to say, during the cleaning, and you have to add that during, if you have a continuous production, for example, make sure that the cleaning bath is in balance and fresh enough to take care of the contaminations that we want to clean away. I don't think I mentioned so much more about that. But in your washing, if you have a washing system with a liquid system, then of course water quality is critical. Depending on what type of water, if you have a hard or soft water in your tap water, so to say, depending on the where you are in the country. You have to add different amount of chemistry or make it softeners, so to say. Also, if you have a water system, bacteria and microorganisms might do so that you have to add some biocides or other chemicals to avoid.
And then
growing.
a little bit, the tendency now is to try to avoid the use of biocides as much as possible. So the challenge is to introduce different ways of controlling the bacteria or microorganisms in the water or in the process baths in order to have them as clean as possible.
Here, the temperature also plays an important role then, of course. Yeah. So if we look at the next slide, what problems can occur? Corrosion is one, of course, thing. If you have metal substrates, can depend on that the cleaning bath is not fresh, or that you have a really high humidity in the process environment when taking up the parts and sending them to the next process steps, or even in between process steps, cleaning steps, so to say. Normally you don't have one cleaning step, you have several in a series. Maybe there had to be you had to add some corrosion inhibitors or change the level of that. Yes, and other problems that can occur with cleaning, of course, if your product is not clean enough, and there's can be millions of reasons, but of course that the cleaning bath is not in good shape, or the surfactant concentration is too low, that you don't have this balance in the bath as wished, or maybe even the wrong choice of cleaning agent. Maybe something has changed in the process. It can be the process step before that the oil or chemicals that is used in the previous step it's changed, and then suddenly the cleaning step is not working anymore. So it always have to be tailor-made, this cleaning cycle parameters with the chemistry and so on to the substrate and the materials that you have to wash away, or the contaminants. And also there can be problems with foam, because if you get foam in your system, you had examples there on the washing equipment with spraying equipment with nozzles. So if you have a too high pressure, for example, you can get foam, and it can be really difficult to get rid of that. And because with foam you don't have an efficient cleaning, so you want to eliminate the foam that is so that can be then also again too old cleaning bath, or too much contamination in the cleaning bath, or the surfactant level or concentration is wrong, and as I mentioned, the high pressure or even wrong product shows. Maybe that's obvious, but so that was about cleaning processes, mainly with based on liquids, but there are of course other cleaning methods to use. For example, CO2 blasting or steam wash. And there are also dry methods with plasma or laser treatment, for example. So depending on what type of process or what type of components you have, you can select other methods that is not, for example, that these dry methods, you don't use any water or chemicals. So that's pros and cons of all processes, of course. But we will talk more about plasma after Emma have talked about the particle cleanliness, because we have one research or many research projects going on that, but one that we will talk about later then. And then this evaluation, or the problem with finding out if a surface is clean enough, that we had one slide of when is it clean enough, and it can be tricky to find out, that's for sure. I mean, there is of course visual inspection to try to either manually or automatically with some vision system, try to see if you can see if it's clean enough, if that's enough for your process. Measurement wise, we have some examples, there are more, but for example, to measure the surface free energy of a surface, that is what you measure is the contact angle. You have a water and a non-polar liquid, and then from that you can calculate the surface free energy. And if you have a higher surface free energy when your water is spread out, easier spreads out on the surface, so you can see if you have cleaned away at least if it's oil or other contaminants. But it can be difficult. I mean, if you want to see if there are no particles on the surface, it depends on where you put this droplet. So then it's not a good method, but it can give you an idea if something happened during the cleaning step. Organic contamination, we have one method here at RISE, IMC. Emma, what was the abbreviation again? I always forget.
I have forgotten right now, actually. So.
Sorry, I thought I did a good. Okay, but the method is that you heat up the surface and then detect. You can detect all organic contamination or compounds on the surface, but that's not an inline method to use. But it's if you want to check like on a batch or so, then that can be used. Also some methods that use UV fluorescence, as the CETA Clinospector to the right is an example of, but there are might be more methods, of course, and also has to be tailor-made for the system used.
And some of them have their limitations. UV fluorescence, it's only for organic compounds that have UV fluorescence. Not everything can be measured with this one. Yeah,
and also you have to you need a difference between your contamination and the compounds in your substrate then to detect if there's a difference, and then a contamination on the surface. But by that, I think we will, I don't know if there are any questions, not in the.
We have one question from the chat, which refers to this pie chart or this cleaning circle. And you already touched a little bit on that in one of the last slides. So Alexei asks, how would you describe this CO2 cleaning or CO2 blasting in this diagram with mechanical, thermal, and chemical and time?
I would say that this referred to the 90% of our presentation now was based on cleaning with washing liquids, where that is more applicable, I think. Yeah, so the CO2 is one of the other methods that I've mentioned at the end. So yeah.
Yeah, but regarding the cycle of mechanical, chemical, it's I would say like all washing methods or cleaning methods are a combination of these four. So in the case of the CO2, it might be more mechanical because of the pressure of the CO2 and
yeah, you can say. And the temperature part then is very tiny. The addition of the contribution of the temperature.
Okay, I see. I would maybe a follow-up question from Alexei. So he says the temperature effect, in his opinion, is not tiny, since it's probably because you have this big delta between part temperature and temperature of your like something like a temperature shock.
Yeah, that might decrease the addition strength of the contaminants to the surface, for example. That's something that needs to be taken in consideration.
But I can't answer how the pie diagram will look if you have the low temperature part, but yeah, we can dig into that later.
So maybe something to continue in the open discussion at the end. Now I would ask Emma to take over. So Emma, the screen is yours. You can take control.
Yep, we're going to check if I can change slides. I'm going to present a little bit about Center for Cleanliness and Technical Cleanliness here at RISE. And I'm trying to change slide. I can't.
Can you use the arrow key that you have on your? Yes.
Yes. Now it's working. Technical cleanliness is what I'm working with, and that is particle cleanliness. And why is that important? It's because if there are harmful particles, it may affect the characteristics of a mechanical system. And it affects surface life because small particles, they wear and tear the systems with fluids in them. And there might be breakdown or sudden loss of function because of larger particles that get stuck or blocking a vital part. It can also impair function over time, which is linked to wear and tear, and that affects the efficiency of the system. It can be slightly slower because of this before you realize that it is not working. And those are not wanted. So you want to have the correct cleanliness level for the system. And as Charlotte talked about before, it's expensive to achieve and it's also expensive to control. Otherwise, it's always good to have less contamination. And cleanliness requirements are introduced on more and more components and systems. The development has been in the automotive industry, which is a big part of what I work for, are for more power and lower weight that lead to higher tolerances and higher demands on cleanliness. For example, a typical engine has the power has tripled since the 70s, while fuel consumption has decreased significantly. And to achieve this, the requirement have increased. And there are also several areas that have driven the development in particle cleanliness. And that's legal requirements, for example, lead-free bearings, and that is more sensitive than bearings with lead. And reduced fuel consumption, and you want to have lower emissions. New security systems, for example, ABS. Increased service intervals, higher demands on sensors, and you also have the electric systems with cameras, lasers, and the engine nowadays. And the status today is that companies have cleanliness requirements on component and systems on critical areas, such as oil systems in an engine or in a fuel system. Usually, the companies have developed their own standards to be followed when analyzing, or it's a reference to general standards, often a combination of this. The standards inform about how the analysis should be carried out to extract particles from the components and how to calculate. Cleanliness demands are often not public, and more systems have cleanliness requirements. We also have a network within this area. It's called Center for Cleanliness, or Centrum för Renhet. It's a membership network which highlights this issue in cleanliness. We perform projects in the field. It's member funding, so you get more for your effort. And you can search public funding with this network to have several companies that work with it. Strategic intelligence, seminars and trainings. And it was started in 2013, I think, because it was a common problem for many industries with the particle cleanliness. And it was important to have an active forum to have networking between different companies and to identify which particles and pollutions to avoid, to know the consequences. And the issue needed to be raised, and there is not always a clear recipients on many companies, both large and small, on who is working with these issues. So therefore, there was need for network. And the companies in this network are manufacturing companies, subcontractors and others, and companies working with surface cleanliness, fat and oil and so on. And it's been from 2013, and it's driven by us at RISE. I'm going to show you, no, this is another slide. I thought I was showing the member companies. Its areas of interest is particle cleanliness, cleanliness regarding processed fluids and oils, fat and salts, production logistics, packaging, storage and transport, and its impact on component cleanliness. The reason this was started is that you have a common problem. We have particles in a fluid system, and the company has a complete requirements. They have a complete system, sets the requirements for the individual components, and the subcontractors needs to meet these requirements, and they don't really know why the requirements are set. So that's a problem. And to understand what influences, the total number of particles sets the requirements. So the most sensitive part sets the levels that are needed, and the most complex part sets the level that can be achieved, and these needs to be matched, and that's quite hard actually. So yeah, and this is a list of the members of the CFR today. So if you are a member of any of these companies, you can just ask me, and then I put you on the mailing list and you get information. And otherwise you can be a member if you ask me, and so on. These are projects that have been driven from 2014 to 2022. So they have different areas. And at RISE, we have that's what I'm going to tell you about Centrum för Enhet. We also have testing of technical cleanliness, and that is made in either of our extraction cabinets. One is with solvent base and one is with water-based cleaning, and we also have ultrasonic equipment if that kind of extraction is needed. And then particles are collected on a filter and tested in a microscope. So here you can see a picture of a fiber that is detected in the microscope. And this is a presentation about how the cleanliness testing is made. I'm not going to go into that. That's in Swedish too. We regularly has educations that are longer than this session today that you can go, and they are in Mölndal mostly. And these are the person working in technical cleanliness, and I think Charlotte showed you pictures of us before. So that was my part of the presentation. Thank you.
Thank you very much, Emma. We have one question / comment that I see in the chat, which refers to total absence of harmful particles, or the amount that allows the system to work according to a specification. And maybe you can comment a bit on that also from the side, like how do you come to the to design and to the amount of contamination that you can allow in the system? Can you test this in some way, or is it some guessing?
That is not. It's a very common question, and it's a very important question. It's the designing of the system, so it's not something we do at RISE. It's how the system works. If you have an engine, for example, how it's designed, what are the different what are the sensitive parts and so on. So unfortunately, no, that's one of the main difficulties in particle cleanliness.
Yeah, probably because of the limited time that we have in the webinar, we cannot really go deep on that, but it's it is about finding this compromise between, as Alexei writes just now, cleanliness, like good enough, doesn't need to be perfect.
Mostly it's not affordable, so that's what limits the cleaning actually. Yes, that's correct.
So for the last few minutes before we go into general discussion, Fabio will present a few more details on ongoing projects on cleanliness at RISE. So Fabio, you can take control. And unmute yourself, please.
Now it works. I couldn't unmute myself. We're presenting some of the projects that we are running now within our department. The first project is called Industrial Water in the Metal Working Industry, or in the metal manufacturing industry. It's a project applied to the FFI Hållbar Produktion 2021. And the main reason for this project is due to the global water stress, that it might be a bit negligible in Sweden. There's a lot of water in Sweden, but it's something that it's starting to worry a lot of companies, and also a lot of companies have sites abroad in places where they are having problems with water sources. So the idea of this project is to the smart recirculation of water and process fluids in the metal manufacturing industry, to try to decrease the consumption of tap water, of chemicals and energy, and generate less waste into the metal manufacturing processes. It's a 2-year project that started in November last year with a total budget of around 10 million crowns, financed by Binova. And we're going to be focusing on different processes in the metal manufacturing industry, like cutting, washing, heat treatment, and cooling water. And we are going to be focused on some of the water and fluid parameters that are necessary in the process baths or in the water treatment facilities that have an impact on the cleanliness or on the washing or on the heat treatment processes. These are some of the parameters that we're going to be looking upon, like hardness, as it might affect the efficiency of the process fluids. Calcium can affect the formation of foam. pH, chloride content for corrosion, how to check the oil content or how to measure it, and different surface tension agents, and how to have a bacterial control or a proper bacterial control in the different processes. The consortium of this project is basically 4 big groups of participants: the OEMs, that are the ones that have the metal manufacturing facilities, chemical suppliers, equipment and sensor suppliers, and from the research side, it's RISE that is involved, IVL, that I don't, it's Institute for...
Svenska Miljöinstitutet.
No.
I don't know the abbreviation, but it's Miljöinstitutet, IVL.
And Chalmers. And what we want to do is, this is a general picture of how more or less the processes are done now, where you have the different types of processes, the cutting, washing, or the heat treatment. You have water and process fluids that are coming into the system, and then they get treated in a certain way for order to separate fluids, oils, and all these emulsions, all these contaminants, and purified or treated water, not purified, treated water back to the municipality. And what we want to do is, in a certain way, close the loop, try to reduce the amount of water coming from the community or from the region or from the nearby water sources, decrease the amount of water that goes to the municipality, and waste. And for that, we want to close the loop as much as possible, or try to recirculate as much as possible water, establish the different water quality parameters and limits for different variables, have a way of measuring these parameters either in the water treatment facilities or in the process baths. And of course, the proper water treatment technologies that can allow us to have the water in the quality conditions required for its recirculation. Together with this, we are planning on doing a water management guideline in order for other facilities or other companies to start recirculating their water or start decreasing their consumption of tap water, and a sustainability analysis to establish or determine what's the impact on the environment of all these measures. The results expected from this stage of the project is to determine the boundaries or limits to the water quality parameters, either in the water treatment facility or in the process baths, a process optimization in a water flow perspective, a good design or methodology for good flowing systems and equipment to find a good match within the different facilities. To try as much as possible to have a chemical-free or biocide-free for bacteria control, as their restrictions are getting tougher in terms of biocides composition, not composition, but use of biocides in the industry. To have to test sensors or systems that can allow us to have an inline measurement of the parameters required, and have a water management plan for assurance of the water quality.
Yes, and I will then mention some words about another ongoing project on the topic, then APPLY, which is where we work with an industrial atmospheric plasma treatment of plastic prior to painting. So it's specific, but I have some, we'll also give you a picture of this cleaning method plasma. So that's why we added this. So if you take the next slide, some project data. It's also FFI Sustainable Production 3-year project. And the idea or the aim is to replace existing cleaning or pre-treatment steps that is used prior to painting of plastic substrates. So by using plasma, as you see on the picture to the right, there it's the atmospheric plasma added to a robot. I have a small film that we will look at also. Then to replace these existing cleaning steps, we will lower the use of chemicals, water and waste, and also energy consumption. So if we take the next slide, why is plasma then a good technique to use? Well, as you probably know, if you want to paint on a plastic substrate, it can be difficult, and it's due to, one thing is the plastic, the low surface energy the plastic has, but also there might be some residuals from the mold when you produce the plastic, and there might be other contaminations such as fingerprints or oils from handling. And the plasma then, what is it? Yeah, that's the fourth state. So you have solid, liquid, gas, and then if you if you higher the temperature or inject even more energy, then you dissociate the molecules in the gas, so it forms a plasma, which is an ionized gas then, highly reactive. So the gas in this case, where we talk about atmospheric plasma, is air, and then this plasma is formed in this nozzle that you have, and then in contact with the surface, this high active plasma then changes the surface. It activates the surface, you say, so that it can open the bondings on the surface, the carbon bonds, but it also has a cleaning effect, as mentioned. So it will look something like this if we have, I think we can maybe stop the film. I think you have the idea, and you saw it's quite a small nozzle, but I mean, if you want to treat then larger parts, and that is one thing that we are looking into in this project, how to automate for complex and more larger surfaces, so to say. You need other type of nozzles, and you can also play with programming the robot in a smart way. But that's what we work with together with these companies, so automotive industry representative, and also other industries. So A&B, for example, producing hearing aids, how do you say? Yeah, small plastic parts for that, and subcontractors to automotive industry, and automotive. So that was our last slide, actually. Yeah. We forgot the thank you slide, but we say it instead. Thank you for listening.